Well, a very good morning. Today we'll be discussing this topic, that is bagging and boosting. Now these two techniques, bagging and boosting, these are the techniques for ensemble learning. And to begin with the bagging part, bagging means to bag. That means to take away something. In Hindi, we could probably say it hathya lena or jhapat lena. So what exactly is meant by bagging and what is being bagged is multiple base models are being bagged here. Now how are these base models being bagged? So they are trained on different subsets and then we'll be combining these models. Now in ensemble learning there were two ways. We had different algorithms and different data sets. And in bagging we'll be combining these two different ways together, that is different algorithms plus different data sets are combined together, and the target advantage, or we can say application area, is the generalization of the model, and plus at the same time overfitting is also prevented as the bias and variance are both balanced in this case. Now here you can see way one of ensemble learning. You can find out that there are multiple models that are there: logistic regression, KNN, decision tree, random forest, SVM, naive bias. So different algorithms are there. This is way one of ensemble learning. Similarly, the way two of ensemble learning was there was one particular model and different data sets were taken from dataset 1 to dataset 6. Now in bagging we'll be combining these two ways together. How come? First is a different algorithm, logistic, KNN, decision tree, random forest, SVM, naive bias, all are combined, and plus these are evaluated or these are learned on different data sets. So both ways, different algorithms and different data sets are being used in bagging. An example of bagging algorithm is random forest, where we have multiple decision trees and the decision trees that are being implemented follows the same approach. Then is the combination techniques that could be used is voting and averaging, both can be used in this case. In voting we have the majority voting technique, where we find the outputs of multiple models, like here it is 0 1, again 0 1 1 1. So majority of them is 1, so output is 1, and these kind of techniques are basically used, suited for classification algorithm because of the discrete nature of the response variable. Similarly, the other technique that could be used is the averaging. We have multiple models that are based on regression, linear, ridge, lasso, polynomial, exponential and logarithmic. Outputs are there, so we'll be averaging all those outputs together. And this is particularly suited for regression algorithm as the nature of the output variable is continuous there. Then is boosting. The word boosting means to boost, boost means to increase. What are we supposed to increase? We are supposed to increase, say, sales. Now what is being boosted here? Here again the multiple models are being boosted. How they are being boosted? Because they are trained sequentially and then they are combined. This is the diagram where we could identify how it is being used. We have the original data. A particular algorithm is used to classify it. Some data points are correct, so they are marked as a right, whereas some misclassifications are there that are made a wrong. Then whatever is wrong, to these wrong certain weights are applied along with the original data also. So weights are updated. Again we'll do the classification using second algorithm. Some will be right, some will be wrong. Wrong will be the misclassification one. To these misclassifications again certain weights are enhanced and then the classification is done. The process continues till we get an optimized amount of accuracy that we are looking for. So this is the technique for boosting. And one particular application area, or you can say example, where this boosting algorithm is used is the ADA boost. Then is the combination technique. Combination technique that is being used for the purpose of boosting is the weighted averaging. So you can use weighted average in case you have the regression problem, and you can use weighted vote in case the problem is of classification 1. Then is comparative analysis. If we talk about training, then training approach that is being followed by bagging is parallel, whereas for boosting it is sequential. Then corresponding the second term, that is the weights in bagging is the uniform, whereas the weights keep on changing in boosting. Then the model combination is averaging or voting, whereas we have a weighted combination in case of boosting. So this is the comparative analysis of the two techniques, bagging and boosting. So we have come to the end, and if you got some knowledge out of this video, then do like, comment, share and subscribe, and thanks for watching.